Alright, in this video we're going to have a look at writing the equations of quadratics using the intercept form. So for this form we're going to need the position of the intercepts, in this case the x-intercept, so there and there. Make sure you have watched the vertex form of the equation before watching this video. I'm going to talk about some things that I covered in that video. Okay, so first thing, like the vertex form, my first two equations, I'm going to have a multiplier of 1 or -1, okay, for my first two examples, sorry. And like I said in that video, in your assessment, you'll have a couple of graphs where you're just told that the multiplier is 1 or -1. So you need to be able to see, well, is it right way up or is it upside down? All right, same as the vertex form equations, what we want to do is we want to start by writing our equation, okay, or the general form of our equation, sorry. So we've got y equals mx plus some number, all in brackets, and then x plus a number in brackets. For this first example, we can see that it's right way up, which means my m is just going to be 1, and we don't tend to write 1 times something, so I can just write nothing there, okay? And I've got x plus some number, or plus or minus some number, and x plus or minus another number. Right, those numbers that go in those brackets come from these intercepts. So we can see that this intercept here is at -2, and this intercept here is at +1. Now, just like the vertex form, anything that goes inside the brackets is the opposite of what we're expecting it to be. So where we've got that -2 intercept, we're going to put +2 inside our brackets. Where we've got the +1 intercept, we're going to put -1. Okay, again, that is just the rule. I need you to just accept that those are the rules, and you're just going to roll with it. All right, example number 2, straight off, look, we can see it's upside down. Okay, and I told you that we're going to have the multiplier of 1 or -1, so multiplier of this one must be -1. Starting off the same as we did before, though, we've got y equals m, x plus or minus some number, and then x plus or minus some number. Then I'm going to put y equals minus. Okay, remember I don't need to write -1, I can just write minus. And then we've got x, close the brackets, x, and close the brackets. Right, numbers that go inside the brackets. We can see this intercept is going through -5. I know that number there looks like a 5, but if we actually count 1, 2, 3, 4, 5, we can see it's -5. So this is going to be +5. We can see this one is going through 0. Plus or minus 0, it actually doesn't matter. Okay, so we can just write it like that. It is perfectly okay to leave your equation like that. Okay, that is fine. However, if we're being pretty awesome, then what we want to do is we want to tidy this up a little bit. Okay, we know plus or minus something, well, we can just write nothing there. All right, and then if we want, we can actually write that x on the other side, and it doesn't even need a bracket because nothing's been added to it. Okay, so that is another way that we could write this equation, but we could stop here if we wanted to. Okay, so I could stop here if I wanted to. All right, down to the last example. Now this one is going to have a multiplier, okay? So remember, those ones require a little bit more work. We do the same thing that we did before. We set up our equation that we're going to be dealing with. Okay, and we find the position of our intercepts. This time I'm going to leave m there because I don't know what m is yet and we need to figure it out. Okay, so we've got an intercept at -3, that becomes +3. We've got an intercept at +2, that becomes -2. Now, same like what we were doing with our vertex form of the equation when we have multipliers, is we need to use another point on the graph, not one that we've already used, to see if we can figure out what the multiplier is. So we're not going to use this point here or this point here because they have already been used. I'm not going to use the vertex because we can't actually tell exactly what the numbers at that vertex will be, what the coordinates would be. So instead, I'm going to use this one here. Okay, I can clearly see that there is the coordinates of that are 1 and 2. Okay, and remember those coordinates, we have x and then we have y. Right, so I'm going to take those coordinates and I'm going to substitute them into my equation. So instead of y, I will have 2. M is what I'm trying to figure out. Excuse me, keep accidentally pushing buttons. And then we have 1 for x, and we still have 1 for x, so we put it in there too. Okay, do a little bit of tidying up. So 1 plus 3 is 4. 1 minus 2 is negative 1. So we have 2 equals m times 4 times negative 1 is negative 4. Okay, we can tidy that up a wee bit. So we have 2 equals negative 4m. Final step, divide both sides. Okay, and we end up with negative 1/2 equals m. Just as a little side note, I've written it as negative 1/2, and you might have written it as y equals is 1 over negative 2. These things are exactly the same, okay? And if we'd put the 1 up the top there too, all these three things here are exactly the same, whether the negative's out the front, down the bottom, or up the top. Right, final step, we need to put that m back into our original equation. Okay, so back into this one here. We get negative 1/2 x plus 3 x minus 2, and that is the final equation. Forgot what I was going to say. Oh, that's it. Just as a double check, it is a good idea to note that when we finished our m, we actually got a negative number, which matches what we're seeing on the graph. The graph is upside down, so it's good that we got a negative going on in there.